Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum wa rahmatullahi wa barakatuh. Today is our 29th lecture of maths, and this is about again the theorems. In the last lecture, we have done first three theorem, and now we will complete over remaining three theorems. These theorems are related with bisector of an angle. In the previous, we learned about the bisector of the line segment. Before starting the theorem, let us see that what is angle bisector. The interior bisector of an angle, also called the internal angle bisector, is the line or line segment that divides the angle into two equal parts. The angle bisector meet at the incenter. It means that the point of congruency of the angle bisector is called incenter. Theorem number 4. Any point on the bisector of an angle is equidistant from its arms. The two lines of the angle are called arms of the angle. You can see clearly in the diagram OB and OA. They both are arms of the angle. OM is a bisector of the angle AOB. OM is the bisector of the angle AOB. Now we will prove that if any point lies on this bisector OM in any place, then that point will be equidistant from the arms, which are OA and OB. They are equidistant from the arm. According to the diagram, we will prove that PQ is congruent to PR. Given the point P is on OM, the notation which lies on OM, this is called ray, because ray has one endpoint. The bisector of the angle AOB. OM is a ray and this is the bisector of the angle AOB. To prove PQ is congruent to PR, P lies on OM, point Q lies on the arm OB, and point R lies on the arm OA. In the construction, we draw two perpendiculars, PQ on OB and PR on OA. Now you see again we have two triangles, OPQ and OPR. We have two triangles, OPQ and OPR. We take the correspondence between these two triangles. OPQ correspond to triangle OPR. We see that which sides or angles are congruent to each other in these two triangles. First, OP is congruent to OP because this is common both the triangles. Angle PQO is congruent to angle PRO because they both are of 90 degree. In the construction, we said that draw two perpendiculars. And I told you before, perpendicular means the angle of 90 degree. So PQO is congruent to POR and they both are equal to, this is PRO not POR, because angle Q and angle R, they both are congruent. This is in construction. PQO is congruent to PRO. This is PRO. PQO is congruent to PRO and we did this in the construction. The second angle POQ congruent to POR. This is given in the statement. Now two angles and one side is congruent. It means that both triangles are congruent. Triangle POQ is congruent to triangle POR, and the postulate will be side angle angle because we use two angles and one side. When triangles are congruent, then each side and each angle will be congruent. We said that PQ is congruent to PR. The reason is corresponding sides of congruent triangles. Theorem 5. This is a converse of theorem 4. They are same that we have done theorem 1 and 2. 2 is a converse of theorem 1. Same theorem 5 is converse of theorem 4. Almost the statement is same. Any point inside an angle equidistant from its arm is on the bisector of it. In this theorem, it is already given that P lies on the bisector, PQ and PR, they both are equal. We will prove that P lies on the bisector of angle AOB. You notice that both the triangles and almost the statement and reasons are same in the direct and converse theorem. Only 2 or 3 points are different in it, and especially proof and given. They both are also the converse of each other. So you should be very careful about the statement. You keep it in mind that which statement will be the end point, which is the second half of the theorem. It will be the proof, and the first half of the statement will be the given. Given that any point P lies inside angle AOB, this portion is called the interior of the interior of the angle, the whole portion. This is called the interior of the angle. And the portion which lies outside the boundary of the angle is called the exterior of the angle. Any point P lies inside angle AOB such that PQ is congruent to PR, PQ is perpendicular to OB, and PR is perpendicular to OA. Now you see that in the converse, the proof and the construction, they both make the given of converse theorem. And to prove point P is on the bisector of angle AOB, this was the given in the previous theorem. The proof was the given in the previous one. Now in this theorem, this is the proof of join P to O. In triangle POQ correspond to triangle POR. In the previous theorem, already given that the bisector of AOB, which was OM. Now there is no bisector of the angle. Only they mentioned that we join P with O. Triangle POQ and POR, they both correspond to each other. Angle PQO is congruent to angle PRO given. This is same in the previous triangle. PO is congruent to PO common, the same that we have done in the previous. Where is the change? In the previous theorem, we also have another angle which was POQ and POR. But here in this theorem, we have PQ is congruent to PR because this is given. Now we have two sides and one angle. Triangles are congruent. So we said that angle side, hypotenuse and side, because the angle is of 90 degree, they both are perpendicular. It means that angle Q and angle R, they both are of 90 degree. When we have a right angle triangle, then in the postulate we write hypotenuse side. Hypotenuse side. You also can write here side, side and angle, but hypotenuse side is antithetic. When two triangles are congruent, it means that each angle, each side of the triangle is congruent to the other one. Hence, angle POQ is congruent to angle POR, corresponding angles of the congruent triangles. That is, P is on the bisector of angle AOB. We prove that P lies on the bisector of angle AOB. In the previous, already given that P lies on the bisector of it, we will prove in that theorem that PQ congruent to PR. Come to the last theorem of this chapter and also our lecture. This is theorem number 6. The bisector of the angles of the triangle are concurrent. Concurrent means they meet on one point and the point of concurrency is I. Point of concurrency means point of intersection of three angle bisectors only given triangle ABC. I told you when the triangle is given for this, we take any two sides or any two angle and we will prove it true for the third side or third angle. In our third theorem, the same triangle is given. We draw the bisectors of two sides and we will prove for the third one. Same here, we take the bisector of any two angle and we will prove that the third angle bisector also meet on the same point. To prove the bisectors of angle A, B and C are concurrent. And the point of concurrency is called what? Incenter. The angle bisectors, the point of concurrency of the angle bisector of the triangle is called incenter. In the construction, we draw two angle bisectors, angle B and angle C. And also we draw two perpendiculars over there, ID on BC and IF on AB and IE on AC. We draw three perpendiculars ID, IF and IE. Statement and reasons. ID is congruent to IF. ID is congruent to IF. According to the diagram, where is I? I lies on the angle bisector of B. The point I lies on the angle bisector of B. So according to the theorem 4, ID and IF, they both are equal. Same we see that ID and IE, ID and IE, they both are congruent. And what is the reason? Because point I lies on the bisector of angle C. So according to the theorem 4, ID and IE, they both are equidistant from the angle bisector. ID is congruent to IF. ID is congruent to IE. It means that IE and IF, they both are congruent to each other. Again, we are using here the transitive property of real numbers. If you remember, in the theorem 4, we also use the same property where OA is congruent to OB, OB is congruent to OC, then we said that OA and OC, they both are congruent. Same situation is here. ID is congruent to IF, ID is congruent to IE. So IE is congruent to IF because both sides are congruent to each other, and also according to the property of transitive, if A is equal to B is equal to C, then we can say that A is equal to C. Also, the point I is on the bisector of angle ABC and BCA. Thus, the bisector of angle A, B, and C are concurrent at I. They are concurrent at I. It means that I is the in center of the given triangle ABC. Okay, students, we have a review exercise. True and false are given here. But you know that we also can make the MCQs of these statements. The first one, bisection means to divide into two equal parts. True. Right bisector, right bisection of line segment means to draw perpendicular which passes through the midpoint of the line segment. Definitely true. This is a definition of bisector or also the statement of the theorem 1. Any point on the right bisector of the line segment is not equidistant from its endpoint. This is false because they are equidistant from its endpoint. Any point equidistant from the endpoints of the line segment is on the right bisector of it. Yes, because this is the statement of the second theorem. The right bisector of the sides of the triangle are not concurrent. False. They are concurrent. The bisector of the angles of the triangle are concurrent. True. We done this in theorem 6. Any point on the bisector of an angle is not equidistant from its arm. This is false because it is equidistant from its arm. Any point inside an angle equidistant from its arm is on the bisector of it. This is true. This is the theorem, the statement of theorem 5. The remaining questions are included in your scheme in our syllabus, but we will do inshallah in 9th senior. Only question 1, true and false, and theorems are included in 9th junior. Okay, students, if you have any problem regarding the theorem or the statement or anything about it, inshallah, we will discuss in the Zoom meeting. Allah Hafiz.